x square plus y square. So first of all I am going to integrate with respect to y. So then we will get integral of x limits are 0 to 1. Okay, now I am going to integrate with respect to y. Then we will get x square y plus y cube by 3 with limits x to root x dx. Now apply the limits, then finally we will get integral of x is equal to 0 to 1, that is x square root x plus root x whole cube by 3 minus of, this is the upper limit. Okay, now for lower limit, x cube plus x cube by 3 dx. Now simplify this complete part. So then we will get integral of x is equal to 0 to 1 x power 5 by 2, this is x power x square, and here 1 by 2 is there. So a power m into a power n formula. So then we get x power 5 by 2 plus x power 3 by 2 by 3 minus of, this is x cube and here x cube is there. Here coefficient is 1 and here 1 by 3 coefficient. So then we get 4 x cube by 3 dx. Now apply the integration for this integrand with respect to x. So by parts we will get integral of x is equal to 0 to 1 x power 5 by 2 plus x power 3 by 2 by 3 minus 4 x cube by 3 dx. So we know that integral of x power m dx equal to x power m plus 1 divided by m plus 1. By applying this formula for here, then we will get 2 by 7 x power 7 by 2 plus 2 by 5 into 1 by 3 x power 5 by 2 minus 4 by 3 x by 4 with limits 0 to 1. Now apply the limits, then we will get 2 by 7 plus 2 by 15 minus 1 by 3, that equal to 3 by 35. So here from the options 2 by 3 by 35, that is option C is the correct option for the given problem. See here in this problem, find the minimum value for the given function. So first of all, take the derivative for the given function. So that is called as f dash of x. So at which x value it is equal to 0, that is called as a station point. So that is assume that x naught. So x is equal to x naught at this point, first derivative equal to 0. Okay, first of all we are going to find the x naught value. Next take the second derivative f dash of x. Now substitute x naught in this equation, f double dash of x naught. Suppose this value is greater than 0. Okay, so if you suppose we get greater than 0, so then f of x naught is nothing but it is equal to minimum value at x naught. Suppose if f double dash of x naught is less than 0, then the given function have maximum value at x naught, that is f of x naught is nothing but having maximum value at x naught. Okay, so now from here in the problem, first take the derivative. So that is f dash of x, that equal to 6x square minus 6x minus 36. Again take the second derivative, f double dash of x, that equal to 12x minus 6. Now equate this equal to 0, then we'll get x is equal to 3. So at x is equal to 3, so this equation is satisfied, that is called x naught. Let us know that this is x naught. Okay, now substitute this value in this equation. This is second step. So then we get 12 into 3 minus 6. So this is nothing but greater than 0. Okay, so whenever this condition is satisfied, so here this condition is satisfied, so then f of x naught means minimum value. Now x naught substitute in this equation, that value is nothing but a minimum value, that is 2 into 3 cube minus 3 into 3 square minus 36 into 3 plus 10, that's equal to minus 71. So by using calculator we will get minus 71. So this is called as a minimum value at x naught equal to 3. So from the options, option D is the correct option. See here in this problem, here one different integral problem is given, integral of 0 to pi sin power 4x cos power 5x dx. So what is the value? First of all, assume that this value equal to I. We know that from the different integral properties, integral of 0 to a f of x dx is equal to integral of 0 to a f of a minus x dx. Okay, now I am going to apply this property here. So then I will get I equal to integral of 0 to pi sine power 4. So here a means pi, so pi minus x cos power 5 pi minus x dx, that equal to integral of 0 to pi sine of pi means sin x only, so sin x power 4, and cos of pi means minus cos x, so if the odd power is there, that means minus 1 whole power 5 cos power 5x, so that's equal to minus of integral 0 to pi sine power 4x cos power 5x dx. So this is nothing but equal to I, so that's equal to I equal to minus I, so 2I equal to 0, I is equal to 0, so this total value equal to 0. So from the options, option is the correct option. See here, double integral problem is given here. Integral 1 to 3 integral 1 to 2 xy square dx dy is given. So here xy square is the function in terms of x and y. Then how can we solve this double integral problem? So first of all, integrate with respect to x. So then afterwards integrate with respect to y. So let's see here. So first of all, integral of 1 to 3 integral of 1 to 2 x y square dx dy. So here y square is a constant term, only I am going to integrate only for x terms. Okay, so then it becomes integral of 1 to 3 y square, so x square by 2 with limits 1 to 2 dy. Okay, now this value is a constant, keep it outside, so x square by 2 1 to 2, so integral of y square means y cube by 3 with limits 1 to 3, so that's equal to 2 minus 1 by 2, 27 by 3 minus 1 by 3, that's equal to 39 by 33, that's equal to 13. So the overall value equal to 13. So option C is the correct option. See here in this problem, here double integration problem is given here. So integral of 0 to 1, integral of 4 by 2 4 e power of x squared dx dy here given here. So here 4 by 2 4 is the x limits and 0 to 1 is the y limits. So write the question as it is first of all. So integral of y is equal to 0 to 1, integral of x is equal to 4 by 2 4, and integral is e power of x square dx dy. So here it cannot be evaluated directly, so it should be solved using the change of order of integration. So first of all, change the order of integration. So first of all, write the limits as it is, that is x limits are x is equal to 4y and here x is equal to 4. Similarly, y limits are y is equal to 0 and y is equal to 1. Now I want the y limits. So first of all, I am taking the y limit is lower is 0. So from y is equal to 0 to, so from this we will get y is equal to x by 4. So these are the y limits. So at a y is equal to 0, x becomes, by substituting that here we will get x is equal to 0 and another x value is 4. So these are the x limits. So these are the new y limits and these are the new x limits. Now substitute here. Integral of x is equal to 0 to 4, integral of y is equal to 0 to x by 4 e power of x square dy dx. So after changing the order of integration, we will get this equation. Now first of all, integrate with respect to y, and here e power x square is there, in terms of x the equation is there, so it is considered constant. So by integrating that, we will get integral of x is equal to 0 to 4. So and this becomes e power x square is constant, and for 1 the integral is y with limits 0 to x by 4 dx. So after simplifying this, we will get integral of x is equal to 0 to 4, so x by 4 e power of x square dx. Now it can be solved by using the substitution method. So substitute x square becomes t. So take the x square is equal to t. Now differentiate that, we will get 2x dx is equal to dt. So from this equation, x dx can be written as dt by 2. So this is the equation 1. Now change the limits. So for x is equal to 0, substitute here, we will get t equal to 0. So for x is equal to 4, so t becomes 16. So these are the t limits. Okay. So here x dx can be replaced with dt by 2 and limits can be replaced with 0 to 16. So then the equation becomes integral of 1 by 4 with limits t equal to 0 to 16 e power t dt by 2. So by simplifying this, we will get 1 by 8 e power t as it is with limits 0 to 16. Now substitute here. So then we will get 1 by 8 into e power 16 minus e power 0. So from this we will get 1 by 8 into e power 16 minus 1. By checking the options, we will get option is the correct option for the given problem. So here in this problem, here double integral of e power y by x dy dx is given here. Here y limits are 0 to x square and x limits are 0 to 4. So that is integral of x is equal to 0 to 4 and y limits are 0 to x square e power of y by x dy dx. So first of all, integrate with respect to y. So it is in the form of e power ax. So we know that integral of e power ax dx is equal to 1 by a into e power ax. Now by applying this formula, we will get integral of x is equal to 0 to 4. So x into e power of y by x with limits 0 to x square dx. So these are the y limits. After applying the limits, we will get integral of x is equal to 0 to 4. So this becomes x into e power x minus x dx. Now integrate it by parts. Here two parts are there. So then it becomes integral of 0 to 4 x into e power x dx minus of integral of 0 to 4 x dx. So it is the integral of UV method. So by applying the UV formula, we will get x e power x minus e power x with limits 0 to 4 minus of this becomes x square by 2 with limits 0 to 4. So by simplifying this, we will get finally 3 e power 4 minus 7. From the options, option D is the correct option for the given problem. See here in this problem, if u is equal to f of x minus y, y minus z, z minus x, so then ux plus uy plus uz, what is the value? So it is a partial differential equation. So here u is a function of x by y terms and y minus z terms and z minus x terms. So first of all, I am going to assume that, so this x by y means r and y minus z means s, and this is called as term t. Okay, so like that I am going to assume that. So that is u is a function of r comma s comma t. Okay, so where r is considered as x minus y and s is considered as y minus z and t is considered as z minus x. Now we want the ux plus uy plus uz. So first of all, find the ux. That means we are going to derive with the x variable with respect to x. So at that time, consider that remaining all variables as constant. So that is dou u by dou x was going to derive it. So u is a function of r s t. So first of all, I am going to take derivative in the r, that is dou u by dou r, and again r is a function of x minus y, that means dou r divided with x plus, now again dou u by dou s, s is again divided with respect to x, dou s by dou x plus dou u by dou t by dou x. So observe here, so this is a very important step. So here u is a derivative with respect to x. So first of all, u is a function of r s t. So first of all, derivative of the u with respect to r. So that function again derivative with respect to x. So like that, with respect to s and with respect to x, with respect to t and with respect to x. Now substitute r s t here. So when you substitute here in this place of r, so r is nothing but x minus y. So here dou u by dou x means derivating with respect to x. So here 1 minus 0 becomes. So dou r by dou x means 1 minus 0. So 1 into dou u by dou r will be remains here. So from this we'll get dou u by dou r, and here we now observe that in s there is no x terms. So this is completely constant. So this becomes completely 0, and from here, so t means z minus x. So it becomes minus 1. So z is 0. Okay, minus means minus of dou u by dou t. So this is the dou u by dou x. So this is considered as equation 1. So similarly, find the uy uz. So in this pattern, okay. So then we will get dou u by dou y. We will get dou u by dou s minus of dou u by dou r. So this is the second equation. Dou u by dou z will get dou u by dou t minus dou u by dou s. So this is the third equation. So here we want add the three equations. So then finally we will get dou u by dou x plus dou u by dou y plus dou u by dou z equal to, so this is on left hand side, on right hand side. So here dou u by dou r, here dou u by dou s is there. So these two terms are going to cancel, and here minus dou u by dou r and dou u by dou t is there. So when you observe in equation 1, so it is minus of minus dou u by dou t, and here plus dou u by dou t, and here minus dou u by dou r, here plus. So totally it becomes equal to 0. So this function complete equal to 0. So from the options, option is the correct option. See here, this is a problem from the partial differential equation here. So here one function is given, that is u is equal to f of x plus cy plus g of x minus cy. So then what is the value of uxx by uyy? So this is the double derivative with respect to x, and this is the double derivative with respect to y. So find the ratio. This is the question. So first of all, I am going to find the ux, that is first derivative. So first derivative the function, that is f dash of x plus cy, and again inner part is there, that is x plus cy. Now I can derivative it, that becomes 1 plus, so cy means yes, this is, no there is no x terms, so then becomes 0 plus next g dash of x minus cy. So here this becomes 1 minus 0. So then we get f dash of x plus cy into 1 plus g dash of x minus cy. So this is the ux, but you want uxx. Now derivate this again with respect to x. So then becomes uxx. So then becomes f double derivative of x plus cy. So derivative with respect to x, then becomes 1 plus, so cy is there is no x terms, that is 0 plus g double dash of x minus cy. So derivative of x means 1 minus of, so derivative of cy means 0. So then we will get f double derivative of x plus cy plus g double derivative of x minus cy. So this is the uxx. Now consider that this is the equation 1. Now similarly find the uyy. So then we will get, first of all find the uy. So from this we will get f derivative of x plus cy, and derivative of x means 0, and derivative of cy means c, plus g derivative of x minus cy. So derivative of inner part is x minus cy. So derivative of x means 0. So for minus cy it becomes minus c. So from this we will get f derivative of x plus cy minus of g derivative of x minus cy. So from this here c is the common, so minus will be placed here. So then we will get c be the outside. Now this is called as uy. Now find the second derivative of y, that is u y y. So again it means here c means constant, kept c outside. Now from inside we will get the same value, that is f derivative of double derivative of x plus cy into c minus of g derivative of x minus cy into minus c. Here minus minus becomes plus, so then it becomes, so c is a common at a time, so it becomes c square into f derivative of x plus cy plus g double derivative of x minus cy. Now this is the second equation. Now observe the first equation and second equation. So this part is completely equal to the from the first equation, so that is uxx. Now replace it, so then we will get uyy equal to c square into uxx. So but we want the uxx by uyy, so bring this term here and c square be here, so it becomes c power minus 2. So the ratio is c power minus 2. From the options, option B the correct option, that is c power minus 2. So the ratio we got c power minus 2. See here in this problem, integral of 0 to pi by 2 sin 2x into log of tan x dx. So let us assume that first of all this is totally equal to I. We know that from the properties of different integrals, so that is integral of 0 to a f of x dx equal to integral of 0 to a f of a minus x dx. So by applying this property we will get integral of 0 to pi by 2 sine of 2 into pi by 2 minus x into log of tan of pi by 2 minus x dx. So this is equal to I. Now here 2 cancel here and it becomes minus 2x, means pi minus 2x. So sine of pi minus 2x is how much? Sine 2x. So that is integral of 0 to pi by 2 sine 2x. So this is equal to sine 2x, and here log of tan of pi by 2 minus x. So tan of pi by 2 minus x is what? Cot x. So that is log of cot x. So cot x can be written as 1 by tan x. That is nothing but tan x whole inverse. So cot x can be replaced as tan x whole inverse dx equal to I. So we know that from the properties of logarithms, that is log a power m equal to m into log a. So bring this minus 1 here by applying this property, then becomes minus 1 into integral 0 to pi by 2 sin 2x into log of tan x dx. So here we can read it as this whole equation is nothing but looking like given equation. So integral 0 to pi by 2 sin 2x log of tan x dx. So it is assumed as I. Okay. Now here minus I equal to I. So bring this sum to right hand side, then becomes 2I equal to 0. So I equal to 0. So it is nothing but equal to 0. So from the options, option is the correct option. See here in this problem, integral of minus pi by 2 pi by 2 x power 10 to log of 1 plus sin x divided by 1 minus sin x under modulus dx given here. Okay, so it is not in the standard format. Now it is a different integral. Now use the different integral property. So that is integral of 0 minus a to a f of x dx equal to 2 times of integral of 0 to a f of x dx when the given function is even function, that is f of minus x equal to f of x. So when it is odd function, that is equal to 0, that is f of minus equal to minus f of x. Now check the given function is even function or odd function first of all. So first of all at the given function, that is f of x equal to x power 10 into log of 1 plus sin x divided by 1 minus sin x dx. So f of minus x, now substitute here, that is here minus x whole power means x power 10 only, there is no change. Log of here sin of minus x means minus sin x, so on the numerator will get 1 minus sin x divided by here 1 plus sin x. Now invert this whole function. So then it becomes x power 10 log of 1 plus sin x divided by 1 minus sin x whole inverse. Okay. Now we know that log of a power m equal to m into log a. So then it becomes minus of. So this is totally equal to given f of x. So that is equal to minus f of x. So f of minus equal to minus f of x. So it is nothing but odd function. So it is nothing but equal to 0. So from the options, option is the correct option.